Good morning, everyone. So for today, we're going to talk about significance level, and we're going to also talk about the z-test statistic. Significance level is the name for a special probability. It's the probability of making the mistake of rejecting the null hypothesis when the hypothesis is true. So for an example, an internet retail business have a pair of hypotheses about P, the proportion of customers who click on an advertisement and then purchase a product from the company. Recall that in the past, the proportion of customers who bought the product was 0.5, and the company hopes this proportion has increased. It tends to test this hypothesis with a significance level of 5%. And all this means is that there's a 5% chance that when we reject the null hypothesis of 15, that we're in fact wrong, that it is actually 15. Right? So, how we do these kind of things is we use, studies and all that stuff. And so when we use the study and do a study a bunch of times, according to this statistic, right, that there's a 5% chance that that if we reject the null hypothesis, we might be wrong, right? That it might be true. Okay, so that's the significance level, right? We'll talk about it. We'll in future lessons. It's just important for this week to know what it is when we see it and to be able to explain what it means. All right, test statistic. It compares the real world with the null hypothesis world, right? So let's break down this thing right here. So if I looked at this, this is my z, right? And how this works is this is my null hypothesis, right? Because remember when we talked about null hypothesis, it's the one where you are allowed to say equal, right? It's the one that you're allowed to say like that has a value that you could test for, right? With the alternative hypothesis, we don't use equal. And so this right here, this p hat, what this is, it's for our sample, right? It's the portion for our sample. And SE is over here. It's when we take our null hypothesis and do 1 minus, we remember this from last unit, and divide it by the sample size. This is our null hypothesis number. Okay. So we're gonna do a problem right now, okay? So the null hypothesis is true, then the z-statistics will be close to zero, all right? And there's a thing called p-value. Now it's a number that measures our surprise. I don't know, it's kind of funny that statisticians, right? We have a number to measure our surprise by reporting the probability that if a null hypothesis is true. So we're going to next lesson, which to be honest, guys, for the rest of the week we're just practicing these, coming up with our null and alternative hypothesis, and coming up with our z-statistics. So next lesson won't be until next week, where we'll look into the math behind the p-value. What we're going to do is I'm going to show you a calculator to plug it into, and I'll always in every assignment put a link to this calculator, and it we'll look how to read it, okay? But you don't just know what the p-value stand for, you know what it means, and it just tells us whether or not to reject our null hypothesis. Okay, let's do an example problem. In December 2011, about 10% of Americans owned an e-reader. In January of 2012, after the holidays, the Pew Research Center conducted a survey of 1,377 randomly selected adults and found that 19% of them owned an e-reader. So right away, right, this is our n, right, because that's our sample. And this is our p hat, because that is our what was in that sample. So if we look back to 10%, 10% own an e-reader, right? And they wanted to conduct a survey. Can the publisher conclude that the ownership increased over the holidays? So that means that 10%, our null hypothesis, right, is that P equals 10%, right? That's the ownership, which is 0.10. And we need it in decimal form, so it's better to write it as 0.10. And HA is that it's bigger than 10%. That's what we want to test out, right? We want to see if it's bigger than 10%. So what we're going to do right now is we're going to go to a calculator. I have not this one, Desmos. Oh, and I got to click this. So Desmos also linked in every activity that we do is going to be the calculator you're going to use for your for this. And so you're going to make a fraction, and then we're going to make a fraction in a fraction, right? And oh, got a little too excited there. Delete my second fraction. So first, before that fraction, you're going to do square root and a fraction and a fraction. So we're going to do the square root of, remember, it's the formula is, right, the null hypothesis, parentheses, 1 minus the null hypothesis divided by our sample size. So our sample size is 1377. Our null hypothesis is 0.10, parentheses, 1 minus 0.10, which is 0.9, but whatever. It's this. I have this marked because it's telling me I need a numerator. So remember, our numerator is going to be our sample, right? What we got for the sample minus what we were expecting to get with the null. And right here is our z-score. Our z-score is 11.13. That's really not close to 0 at all, right? It's really high. And we're going to put it into this 11.13. We're going to put it into this calculator, shady calculator, right? All these ads, but hit calculate, and then, all right, sometimes it takes a little while. We're just waiting for this to tell us when it loads if we should be surprised or not mathematically. All right, I'll tell you right now though, 11.13 for a z-score is pretty high, so we can reject the null hypothesis. Let's see. Oh, here it is. P-value is less than 0.00001. The result is significant, right? So that means that we can reject our null hypothesis. Let's try a different one. Let's try another problem. All right. So, but before we talk about that, the steps, right? You identify the null hypothesis. You identified your p-hat, and you identified your sample size, and you're good to go with these types of problems, right? So let's do this one, okay? Suppose we're testing people to see if the rate of of use of seatbelts has changed from previous value of 88%, right? So these percentages are helpful. So H naught is P is equal to 88%, right? We want to see if it's increased. So HA is P is greater than 88%. All right, so the sample size of 500, all right, and we see that 450 have the seatbelts fastened. Okay, so we're gonna have to do a little bit of extra math, right? Because they didn't give us a percentage, they gave us a number, but that's not a problem because we just have to remember to find the percentage, you just have to do 450 divided by 500. And our sample size is 500, right? That's n. So we basically have everything we need to plug it into our calculator. So we go into our calculator. Mr. Pilisher is lazy, so he's going to just use 0.88, right? 1 minus, leave it alone, and then 0.88, 500 on the bottom. 0.1 becomes 0.88. And 19, we have to find out, that's going to have to be a fraction of 450 minus 500. All right? Which is, by the way, if you do it in your calculator or if you just do it, it's 0.9. All right, so it's 1.37 is our z-score. That's, well, that's you know, that's not as big as 11. are we surprised? Can we reject the null hypothesis? So we put in 1.37. We hit calculate. We go down. Ah, look, this time it's red. This time it's red. This is not significant. Yeah, so it's telling us that it can't be rejected, right? This is not surprised. So so the null hypothesis, for this one, we can't reject the null hypothesis. Now, if this P stuff is confusing you, don't worry. We are not, for the next week, you're not going to be finding the P like that. There's a reason why I pulled out that calculator. If we had our textbooks, there's a table that we could have used. So I don't want you to freak out. So the only thing you have to find out is the z-score. And in order to find the z-score, you just have to use these two things. You have to find the significant error, and then you have to take your the sample proportion minus the null hypothesis proportion and divide it by the sample error. And to do that, you can use the Desmos scientific calculator, and it's desmos.com/scientific, and that's all you have to do this week. Okay? Okay.